Hello everyone. See the question. Why is pulling lawn roller preferred to pushing it? So instead of pushing, why we are always preferring pulling? That is what we have to tell. So let's see. Now, first case I am taking, that is pulling. Let a lawn roller is pulled by force F, which makes angle theta with horizontal. You can see the diagram. See here, this is a lawn roller. The diagram we can say, which shows in which direction which force is acting. So this is the force with which we are pulling this lawn roller, which makes angle theta with the horizontal. So if we have resolved these components of the force, this component becomes F cos theta, this component becomes F sin theta. Normal reaction is always in upward direction. The weight of the lawn roller is acting vertically downward, that is mg, and this side, that is frictional force, which is opposite to the direction of motion. Yes, this F is frictional force. Now from diagram you can see this N and F sin theta are in one direction and this mg is in opposite direction. That's why addition of these two forces is equal to this, and therefore N plus F sin theta is equal to mg. Now I want to find N, so I am transferring this F sin theta this side. So what I will get, N is equal to, that is normal reaction is equal to mg minus F sin theta. Now frictional force F is equal to mu into N, where mu is the coefficient of friction. So F is equal to mu times N. Now N value we know, in case of pulling we got mg minus F sin theta. Let's substitute here and we will get F is equal to mu into mg minus F sin theta. Let's call this as equation number 1, and this is the frictional force in case of pulling. Now let's move ahead. For pushing case, let a lawn roller is pushed by force F in the direction as shown in the figure. So see the figure here. You see now, like this we have pushed this lawn roller, and again this angle is theta. Now I am resolving again these components. So this side you are getting F cos theta, this side F sin theta, downward is mg, upward is normal reaction, and opposite to the motion, it is what? Frictional force. What is the difference between these two diagrams? This F sin theta component you was getting in upward direction in case of pulling, whereas F sin theta component we are getting in downward direction in case of pushing. So let's find out normal reaction now from this diagram. So from diagram again, N is equal to, now this time in upward direction you have only normal reaction, downward direction you have F sin theta plus mg. So that's why normal reaction is equal to F sin theta plus mg. Now frictional force again, F is equal to mu N, and therefore let's substitute this N value. What we will get? F is equal to mu into mg plus F sin theta. You can write F sin theta plus mg or mg plus F sin theta. No need to worry about it. So F is equal to mu into mg plus F sin theta. Let's call this as equation number 2. Now if we will compare the equation 1, that is in case of pulling, and equation 2, that is in case of pushing, we can easily say that frictional force is less in case of pulling and frictional force is more in case of pulling, and therefore from equation 1 and 2, frictional force is less in pulling case as compared with pushing, hence pulling is easier than pushing, or we can say pulling is always preferred than pushing a lawn roller. Okay, so learn this resolution of component of force, learn to make the equations, try to find out frictional force in each case, and make conversion. Okay, note down this all, go through it once. Okay, thank you.